All right, good afternoon again, students. This is Mr. Kutsi. What I'm going to be talking about today is polynomial functions and the end behavior. And basically, you'll hear me here say end behavior quite a bit, and everything in this chapter, in chapter 5, is polynomial functions. So what it is there's four possibilities. So in your notes, what you want to do is you're going to set up four graphs there, because there's four different things that could happen with a polynomial function. All right. Okay. So here's what we have. The four things that can happen are basically this. If you think of a polynomial function, there are things like x squared, x cubed, x to the fourth, anything with an exponent. All right. So for example, parabolas. Parabolas are a perfect example of a polynomial function. Now all we care about though are the end behavior at this point. So for a parabola, it might go up on both sides, or both sides of it might be going down. I don't know where the rest of the parabola is. I don't care right now. We're just talking about its end behavior. So that's one type of thing that might happen. Or two types. It could be up, up, or it could be down, down. Down on both sides. The other thing that could happen, it could be down on one side and up on the other, or up on the negative side and down on the positive side. Okay. So what we're going to be concerned with here is the positive and the negative x-axis. The negative and the positive. The positive x-axis. Okay. So the negatives and the positives. So I don't expect everyone to memorize what these four things are, but you do want to know that's what four things can happen, and I'm going to show you now the method for how do you figure out which one is which. So keep that. I'm going to keep some space here, and we're going to slide down. So leave some space here because this is going to be important. I'm going to put a box around that, but I'm going to leave some space underneath those graphs. So for my end behavior, I'm leaving some space underneath there. Okay, so we'll do some examples and we'll come back up top. So let's do an example like 3x to the fourth plus 5x plus 10. Now, to be honest with you, the rest of this stuff doesn't matter, and here's why. X to the fourth is going to increase so much faster than a regular x. It's the dominant thing here. So what we're going to focus on, this front part of the equation. And again, we said we're doing end behavior. So we're not going to do a complete table of values. We're just going to do like sort of the end values. Where are the ends of the graph? So to give an example, the far end of the graph might be, negative infinity. Okay, well, we can't try negative infinity. We'll try negative 10 because negative 10 to the fourth is already going to be huge. And then we'll also try positive 10 because, again, 10 to the fourth is going to be huge. Not infinity, but it's going to be far enough on our graph to tell us what's going on. So here's the idea. If I took negative 10 and plugged it in here to the fourth power, I'd have 3 times negative 10 to the fourth. Now the key here is fourth power, negative 10. That's going to end up being a positive 10,000. And our answer is positive. All right, as you can see, I'm clearly recording this during the school day, so sorry about that. Okay, so anyways, the negative to the fourth comes out as a positive, and this gives us positive 30,000. That's huge. Okay. Now when we try a positive, it'd be positive 10 to the fourth. We still have 3 times 10,000. And so again, we're going to have about 30,000. Okay, so huge. Okay, so what does that tell us? Well, that tells us what's going on here. That tells us that if you tried a negative 10, the answer came out as a positive 30,000. So really huge. So it's way up there. And on the positive 10 side, again, 30,000. So it's, again, huge, way up there. So that means our end behavior is up, up, or up on the left, up on the right. There's different ways to write this, but for now, let's just focus on being able to make a quick sketch like that. No middle part required, just the ends. That's why it's called end behavior. Okay, now, our next example then will cover the case of, what if we have the same numbers, and again, since we only care about the beginning, I'll just put dot, dot, dot. The rest of it's going to be the same as that. What if we have the same equation, but with a negative 3x to the 4? So what I want to talk about then is, how would that switch it? Now, some of you may already know from the previous chapters, but let's say you didn't. Let's say you forgot the shortcuts we know already. So if we did this again, we'd have negative 3 times negative 10 to the 4th, which would be negative 3 times negative 10 to the 4th is still going to be 10,000. But this time we have a negative 3 in front, so it's going to be negative 30,000. So this time it's actually going down. Okay, same thing with the positive 10. We have negative 3 times positive 10 to the 4th power, which is going to be negative 3 times 10,000, going to be negative 30,000. So again, same as our graph before, but this time when we tried a negative 10, it came really big negative, negative 30,000. This time when we tried positive 10, the answer came out really big negative, negative 30,000. Okay, so positive went up, up. When we put that negative in front of this one, it went down, down. That's what we're trying to identify and be able to predict in the future with these graphs. All right, let me slide this paper up a little bit. We're sort of running out of room. See if we can still fit our last two problems on here and just a little bit of space. So let's take a look at, we tried an even exponent. Let's try an odd exponent. And 2x to the 3rd plus, and dot, dot, dot. I don't care about the rest of the equation. We don't care. Okay, so again, we're going to try a negative 10 and a positive 10 and see what's going to happen here. So, negative 10 into here. We got 2 times negative 10 to the 3rd. Okay, we're plugging in just into this front part here. Now, this time, a negative to the 3rd power. Well, 10 to the 3rd is going to have 3 zeros. That's 1,000. A negative, though, a negative to the 3rd stays negative. That's the key. And we get negative 2,000. All right. With the final one, plugging 10 in here. Now with the positive, not the final one, the positive one I meant to say. With the positive 10, because it starts positive, the answer stays positive. And now we get a positive 2,000. So what's happening here with this little graph here? Negative 10 came out negative 2,000. A negative 10, this is our negative x-axis, came out negative 10,000. Trying a positive 10 when x is positive 10, it came out positive. So the upside, the positive side is going to go upwards. All right. See, make sure that makes sense. We plugged in negative 10. A negative gave us a negative. A positive gave us a positive, so that's why it's up in the positive side. All right, last one here, and we're going to wrap this up. Negative 2x to the 3rd. Same numbers, but now we have a negative. And I'll explain in a second why I chose the numbers I chose. So this time, last one here, negative and a positive 10. Negative 10 to the 3rd power, again. That's going to give us negative 1,000. The difference here is we have a negative 2 in front. So negative times a negative, this one will turn back to a positive 2,000. Same thing again. When it starts positive, we had a 3rd power here, 3rd power here. We get a negative 2 and then 1,000. Negative 2 times 1,000. And so that's negative 2,000. Okay. So the key here is that with the 3rd power, if it's negative, it stays negative. If it's positive, it stays positive. So what happens then is you plugged in a negative 10 and got a positive 2,000. So even though we're on the negative side, we're going in the positive direction. Okay. This one, a positive 10 and a negative 2,000. Again, we're on the positive side, but we're ending up with a negative value. Okay. So that doesn't make sense. Take a second, go back over that again. And what we're going to do right now, you can pause it, go review, rewind this video, whatever. Because what we're going to do is going to transfer that information back up to the top. Okay. Back up to the top here, our example that was up, that was this one right here, 3x to the 4. Okay. Our one that went down was also 3x to the 4, but it was negative 3x to the 4. Okay. The next two, down and up. The example we used was 2x cubed. And then the one that went up, down, the example we used was the negative 2x cubed. Okay, so there's two things you want, oops, sorry, there we go. This is what we want to focus on now. There's two things you want to look for in both of them. The front number is important, as well as the exponent is very important. So those two things, front number is important, front number is important, front number is important, and the exponent. Okay, so what this is, the rule here is that if you have a positive number and
Hey, Sixers.
okay, so if you have a positive coefficient, a positive number in front, and an even exponent, that's going to be your up case. If you have a negative number and an even exponent, then it's going to be down. The negative is going to flip it upside down. So basically, the thing is the evens are going to go either up or down. Even exponent is one of these two cases. So what does that mean? That means that over here, the odd cases, the odd exponents, are going to go in opposite directions. So that's the way I memorize that. Odd exponent, opposite direction. Odd is opposite. All right. Now in this case, you have positive number in front and an odd exponent. Over here, you had a negative number in front and an odd exponent. All right, that's all the notes you need for this, and you should be totally ready to start graphing the end behavior of polynomial functions. Thanks for watching, and see you in class.